No matter how many times you hit the 8-ball, the cue ball always slows down. No matter how many times you hit the nail, the hammer always slows down. And it doesn't matter if it's an elastic collision like that cue ball, or an inelastic collision where they stick together like these toy cars. The object that does the hitting always slows down. It also doesn't matter if the object is broken down into smaller pieces, as the speed of the object hitting all the pieces always slows down. Conservation of momentum is a fundamental law of physics that cannot be broken. So what do the fundamental laws of physics have to do with the events of 9/11? Everything. Most people don't realize that World Trade Centers 1, 2, and 7 did not slow down when they fell. Careful measurements, such as this one by David Chandler, clearly indicates that the velocity of the roof of the towers actually sped up. How can this be? The National Institute of Standards and Technology, or NIST, was tasked with investigating the collapse, but they stopped their investigation at the very moment the roof began to fall. By stopping their study early, they never addressed the physics of the actual fall and just assumed that the collapse was inevitable. But in science, one needs to be very careful when making such bold assumptions. Instead, NIST relies on the work of Professor Bazant and others with their collapse analysis. To explain the energy needed, their hypothesis relies on the notion that the upper block physically crushed the lower concrete floors into dust. They claim the upper, smaller block of the tower crushed the larger, lower block down to the ground, and then the upper block finally crushed itself. In addition, they state that a simultaneous crush down of the tower and crush up of the upper falling block is impossible. But independent analysis refutes the official hypothesis because we do not observe a deceleration or jolt, which is necessary to crush the concrete below. In addition, any block that is dropped on a larger block of the same material would in turn also destroy itself well before it could destroy all of the larger block below. Newton's third law of motion says that for every force there is an opposite but equal force. So any force imparted by a falling block striking a lower block must also impart the same force on the upper block. What the independent studies are really saying is that there is only one mechanism that could cause an accelerating roof, and that is if some outside force, such as explosives, remove the supports below first, allowing the roof to speed up. Obviously, both hypotheses cannot be correct, so how can we tell who's right? By conducting some experiments, the arbitrator of opposing hypotheses. Richard Feynman was a brilliant physicist and a member on the panel that investigated the Challenger disaster, who conducted a simple experiment using ice water to demonstrate the effect of temperature on a piece of the shuttle's seal. He said, "It doesn't matter how beautiful your theory is. It doesn't matter how smart you are. If it doesn't agree with experiment, it's wrong." Let's observe some simple experiments to help resolve the following questions. Does the upper block of material slow down or speed up when it hits the lower block? Can the upper block destroy a lower block of the same material without destroying itself in the process? And can the crush down of a lower part be simultaneous with the crush up of the upper part? In order to control the direction of the falling blocks, I built a frame guide rail system out of aluminum angle that was slightly larger than my test blocks. My first material was ice. Raising the top block, I let it fall on the lower block and observed the results. The first thing I observed is that the top block decelerates very rapidly. The second thing observed is that both the upper and lower ice block disintegrated in part each time it hit the lower mass. The ice was difficult to completely break, taking over 100 drops to reduce its size, which is why only excerpts of this video is shown here. Eventually, the upper block broke to such a small piece that it was no longer usable. The lower block was broken about the same distance, however, most of the lower block remained intact. A weak mix of mortar was poured into forms and cured for approximately 1 day. Using the same guide rails, the top block of mortar was dropped onto the larger lower block. Just like the ice block drop, the top block decelerated the moment it hit the lower mass. The lower block did not shatter, but rather slowly chipped off at about the same rate as the upper block. I continued to drop the upper block many times, and again the video is truncated for brevity. The lower block was so fragile that it cracked in half when I slid it out to observe the progress, making it even weaker for the top block to crush. Nevertheless, it still took over 60 drops to demolish the upper block, and similar to the ice block, the upper block destroyed itself before the lower one was completely destroyed. Both towers held the upper block of floors for about 1 hour after the planes hit, meaning the total equivalent supporting force must be equal to the downward weight of the floors. The goal of the next experiment is to see if a force that can initially support a static load can also cause the same falling load to noticeably slow down when dropped. A wood block was gently wedged so that it just barely held the upper block in the static condition. Raising the block and dropping it, you can clearly see that the block decelerated as it hit the support, indicating that a deceleration will be noticed by a falling body by any equivalent force that could support the static weight. Next, I constructed a much larger guide rail system in order to guide a falling hollow concrete block onto a stack of 4 similar concrete blocks. The goal was to see if the concrete block falling would crush the lower 4 hollow blocks before it crushed itself, and to see if it would continually accelerate with the accreting mass. The concrete block was raised to the 12-foot mark, equivalent to the floor spacing on the twin towers, and then let go. The falling block decelerated rapidly after it hit the lower stack and destroyed both the falling block and the top block virtually simultaneously. However, it did not destroy the lower 3 blocks. The test was repeated with the same blocks, only this time the holes in the blocks were alternated 90 degrees to each other. Similar results were observed. Finally, some very small, weak half blocks were used. The results were identical, however, due to the lack of support from the guide rails they tipped over, but not until after they yielded the same results. The next 3 experiments are real-world examples intended to see if, indeed, as NIST simply assumed, a collapse would be inevitable. Will the collapse of these structures continue to accelerate? And is collapse really inevitable? Based on these 3 real-world examples, an accelerated, straight-down collapse of the structures certainly is not inevitable. These are simple experiments, but like Feynman's ice water used for the space shuttle, they demonstrate fundamental laws that will not be fooled by the so-called experts, even with all their funding and fancy equations. What was demonstrated by this experiment is, 1. Any upper block of material must slow down when it hits any mass or force that previously supported it. 2. The upper block of a falling structure will destroy itself well before it can possibly crush the entire larger lower block. 3. The crush down of the lower block can be virtually simultaneous to the crush up of the falling block. The fact that the upper block of the World Trade Center was observed to speed up cannot be explained with a natural gravitational collapse. What you are observing are rapidly timed explosives blowing out the supporting structure, allowing the roof line to accelerate. Explosives also account for all other evidence found, such as the eutectic steel found by FEMA, the iron microspheres found by the USGS, and the high explosive active nanothermite found in the dust, none of which was addressed by NIST. Perhaps there are experiments that support the official hypothesis that match what we observed, but I cannot think of one. There is no sense trying to support the official position with words until such time as a repeatable experiment that clearly demonstrates what we observed can be presented. Since the experiments does not match the Bazant hypothesis, it's wrong. NIST assumption that the towers collapse was inevitable is also wrong. The controlled demolition hypothesis is the only one that can be supported by experiment using the scientific method. Always remember the thousands of people that were intentionally murdered that day, and the unnatural acceleration of the towers that defy the laws of physics without assistance from explosives the next time you hit a nail with your hammer or play a game of pool.